Number 33. The cholesterol level is given by that. Our raw box plot represent the data. So first we have to do all of this, find the outliers and everything. But luckily we have the data that is in increasing order. There's 30 of them, so the median will be right in the middle, so between the 15 and the 16. 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, and so the median will be between those two. The median, another symbol for the median is the second quartile. So the middle of the average of those two. (196.5). And then we find the first quartile and the third quartile. The first quartile is from that the lower half, and there will be 10, 12, 14, and 15. So therefore 15 of them. So that will be the one on the 8 will be right in the middle. So the middle of the lower 15 number, the middle of that. 1, 2, 3, 4, 5, 6, 7, 8. And then for the upper 15, that will be the 8. 1, 2, 3, 4, 5, 6, 7, 8. And so next we find the interquartile range. Q3 minus Q1, 221 minus 180, that will be 41. Right, next, the fences. Upper fences will be from the third quartile plus 1.5 times the interquartile range. So 221 plus 1.5 times 41. To 82.5. And the lower fence from the first quartile 1.5 interquartile range below it, so which is 180 minus 1.5 times 41. $118.5. Right, so that will be the fences. Now we put all of that together. First quartile is 180 raw bar, 220, 196.5. That the median, 221. That the third quartile, we draw the box for that. This is the box. The fences will be at 282.5 and the low fence 118.5. Now the data we will draw up to the lowest one that's not in the fence. That will be 275, and the highest within the fence and the lowest within the fence is 154. course we can draw other number too, 96.5, 221, 180. Now if there is any outliers, let's say this instead of, if there's the 300, I will draw an asterisk like that. Any outlier will be denoted by an asterisk on the outside like this. But in this case we do not have any outliers. So that's what we have. Right. Next, compute the linear correlation coefficient between the two variables and determine whether the linear relation exists. Right. So this will be very easy. We just put both of them to list 1 and list 2. Of this problem, we're using the calculator. Right, just put x and y for L1, L2. So what we do here is we'll calculate, see if there are any relation between the data. So go to number stat and then calculate linear regression and calculate. Right, if this is we get, don't worry, we need the R too. We need the R. So we only need to do this one time for the calculator. So second catalog all the way down until you see diagnostic. Right, diagnostics on, hit enter. That's that. Now do that again. Stat, calculate linear regression. Yeah, we have R is 0.9827. And that's a very high number. That is close to 1. The closer this is to 1 or -1, the better the relation. So this one very close to 1. So this the relation surely exists there. Right? So pretty much just that. Again, just put x into list 1, 1 to list 2, and then find the relation. If that number between, this number always between -1 and 1, but the closer it is to -1 or 1, the better the relation is. So we choose that, and of course that would be wrong because that's a very high number to 1. Right. Not only that, we can certainly tell if the data are related. We can also find the equation to represent it as well. So to do that, we then once again enter x and y into list 1, list 2. Right, so I do that. Timestamp. First I'm going to clear the list here. And enter those number of x into list 1. And then y for list 2. Right, double check. And once again, stat, calculate linear regression. Right, so we have that. So this is, if I'm going to write ax plus b, where a is 2.096, 7, and b is minus 0.552. Right, so just that. Right, next, the data below are ages and that. So again, the two lists x and y. One for x, list 1, one for list 2, and then we find the relation if there's any based on the r. By the way, if r is close to 1 like this, is very good. Right. Once again, I'll highlight it. We have to clear it first, and then we enter this in. 38, 41, 45, 48, 51, 53, 57, 61, and 65. Then the other one, 116, 120, 123, 131, 142, 145, 148, 150, and 152. $38, $41, $45, $48, $51, $53, $57, $61, and $65. 116, 120, 123, 131, 142, 145, 148, 150, 152. So let's go. Just calculate the linear regression. If we want to, we can store the equation into something like, if I want, let's say, store that into y1, for instance. Another way to get y1 is alpha trace or variable, y variable function y1. We don't even need to do this. Calculate, right, very strongly related, it's good. And the equation, we can just write this down. So by equal to 1.49. They use two decimal places, so I just use that. And then plus 60.46. Right. What's going to be that? Right. Next is that what would be the predicted pressure if the age was 60? So 60 in this range, so it's good. If asked for 100, we don't use the formula because that's outside the data range here. So I'm just going to put 60 here, so that's 1.49 times 50. 60. If x is equal to 60, have 153.86. Of course, remember we store the data into here, right? Into y1. So we need to do is recall the y1 and say we evaluate that when x equal to 60. Yeah, of course that will be a better accurate because the rounding error that will round up to 1.49, that changed a lot. Right, timestamp. Right, next we go to probability. So which of the following probabilities for the sample point ABC could be true if ABC are only sample point of the experiment? Right, so a few properties that we need to is, if we only have 3, so the probability, if we add all of them up, it has to be 1. And none of the probability can be negative or more than 1. So something like this, it doesn't work because probability cannot be negative. Next, the probability have to add up to 1. So this add up to 1. The first one is good. This 1/4, 1/4, 1/4 is not enough. So the sum is not equal to 1. It's not good. 1/8 plus 1/9 plus 1/5, there's no way it is 1. So the sum is not equal to 1 either. So everything have to be between 0 and 1, and the sum, when you add all of them up, has to be 1. So probability of anything between 1, 0, and the sum of each point have to be equal to 1. So we have to have those two properties. Right, next, use the spinner below to answer the question. Assume that it is equally probable that the pointer will land on any of the 5 number spaces. If the pointer land on the border line, spin again. Find the probability that will land on an odd number. So here the sample space we have from 1 to 5. And the event of getting an odd number is 1, 3, and 5. And the most fundamental probability of an event is counting how many we have in the event divided by how many we have in the sample space. So this is 3 over 5. So that's very straightforward. Right, next. A single die is rolled twice. The set of 36 equally likely outcome is listed below. So there are 2 dice. The first one could be anywhere from 1 to 6. The second one anywhere from 1 to 6. So 6 times 6, 36 outcomes. So we know the sample space is this, 36 outcomes. Now find the probability of getting a sum is greater than 9. So let's just count how many we have of the event where sum is greater than 9. We can list them, but or we can count them. Greater than 9, not equal to. Right, so for 6, 10, 5, 5, 5, 6, 6, 5, and 6, 4, sorry, 6, 6. So pretty much where the sum is equal to 10, 6, 4, 4, 6, and 5, 5, and sum equal to 11, 5, 6, 6, 5, and the sum equal to 12. And we count how many we have, 1, 2, 3, 4, 5, 6, and the probability of getting that event is how many we have in that event over how many we have of the sample space. So this 6 over 36 will reduce to 1 over 6. On the calculator, 6 divided by 36, change to fraction, 1 over 6. So pretty much that. The table below show the probability generated by rolling one die 50 times and noting the up phase. So that's what we have. What is the probability of getting an up phase of an odd number? So odd numbers here, 1, 3, or 5. Simply we just add all those up. That's 0.58. Should be that, just that. Right, next. Probability experiment is conducted in which the sample space of the experiment from 1 to 15, right? Let event A be 5, 6, 7, 8, B 7, 8, 9, 10, and 11. Assume that each outcome is equally likely. List the outcome in A and B. The word "and" here meaning the overlap or something in common. And if there's nothing in common, it is called mutually exclusive. When there's no common elements. Right, so of course when we look at this, the 7 and 8 belong to both A and B because they have something in common. They are not mutually exclusive. This is N. The OR will be 5, 6, 7, 8, 9, 10 to 11. So this is going to be OR. But we look for N. Alright, next. The table lists the drinking habit of a group of college students. If a student is chosen at random, find the probability of getting someone who is a woman or a heavy drinker. So pretty much we just count a woman or a heavy drinker. Of course, we're not counting the total, sorry. Right, we just count women or heavy drinker. So we just add all this up. June 27. So how many we have in that event over the total? Sorry, I had the wrong one. 227 divided by 421. Right, and of course we convert to percentage, or we just give decimal. Right. A probability experiment is conducted with the sample space the experiment is, so we have from 2 to 12. Event A is 5, 6, 7, 8, 9. Assume that each outcome is equally likely. List all the outcomes in the complement of A. So the upper case C meaning the complement. Meaning something is not in A. So see, not in A, pretty much everything except 5, 6, 7, 8, 9. So what's left is the complement. So in the sample space, we take out everything in A. Left us with this 6 number. And then as for the probability, just count 1, 2, 3, 4, 5, 6 out of 2, 3, 6, 1, 7, 8, 9, 10, 11. Right, so pretty much just that. Of course, we also have the properties of probability of the complement is equal to 1 minus the probability of getting A. So, right. So the complement is something that is not in the event. A game has 3 outcomes. The probability of winning is 0.4, tie is 0.5, and loss is 0.1. What is the probability of not winning in a single play of the game? So not winning is complement of winning. Win is 0.4. So we say it just like the complement rule here. Probability of not win is equal to 1 minus probability of winning. 1 minus 0.4 is equal to 0.6. Right, so we just have that. A single die is rolled twice. Find the probability of getting a 6 at the first time and a 3 on the second time. Right. So we just roll 2 times. The first one is a 6. So that's 1 out of 6 choice. There's a single, let's say that the standard die, 6 faces. So to get 6, 1 out of 6. To get 3 on the second time, 1 out of 6 again. Because there's 6 faces and we only got 1 out of 6. And so just simply multiply them. 1.6 times 1 over 6 times 1 over 6 is 1 over 36. Multiply straight across. Right. Next, a bag contains 10 white, 12 blue, 13 red, 4 yellow, and 8 green. Good bones. A bone selected in the bag, the color is noted, then replaced. You then draw a second bone, note the color, then replace. What is the probability of getting 2 red bones? So we're gonna get the red on the first one and red on the second one. And then 13 red. Out of how many? 10, 12, 13. That looks like 50. That's 50. And to the first one is 13 and 50. Right. Now, have to read the question carefully. We pick the ball out, color noted, then replace. So we're not going to keep it. If we keep it, there will be 49 left in the bag. If we replace it, that means put it back, and there's still 50 of them, and there's still 13 red. So notice that this one, we do not keep it. If we keep it, there will only 59 left, 49 left in the bag, and there's only 12 left in the bag that are red. But when we have this, so 13 times 13, 50 times 13, 15. Or just say the fraction. 13 over 50 times 13 over 50. We want 69 over 2500. We can convert it to decimal. 0.676. Right, so we just have that. Next, there are 35 chocolate in the box, all identically shaped. 8 with nuts, 11 with caramel, and 16 with chocolate, solid chocolate. You then select one, eat it, and then select the second piece. Find the probability of select 2 solid in a row. So this one is slightly different than the previous one. The previous one, when we pick one, we replace it. This one, when we select one, we eat it. So there should be one less in the box. Original there's 35, and there's 16 solid in the box. But we ate the first one, so now only 34 left. And we ate the first one, if it is solid, there's only 15 left. That is solid. So multiply straight across, and that's all we have. (24 over 119). Right, so that's what we have.